Good afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. So, in this video, we are going to discuss about recurrence relations. So, what is meant by recurrence relation? What is the general form of recurrence relation? So, and we can understand the recurrence relation by considering some example problems. So, what is meant by recurrence relation? A sequence is a function. What the sequence consisting of is some integer 0, 1, 2, 3 and so on up to some infinity. Or it can start from 1, 2, 3, 4 up to infinity. So, these are called as a set of numbers or set of integers. These sequence of integers, instead of writing each and every term, that is 0, 1, 2, 3, we can denoting as a simple expression, simple term, that is called as an. An denoting the, instead of writing every integer in the sequence, we can write the generalized term that is called as an, where n is starts from 0 to infinity. Then a1 means the first number in the sequence, a2 means second number in the sequence. Like that, we need to write the generalized term. Then the term that is used to denoting the sequence of integers is called as an. An is called as a term of the sequence. For example, consider the sequence an equal to 1 by n. So, for example, instead of writing 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, instead of writing each and every fractional, that is a 1 by 2, 1 by 3, 1 by 4, we can simply write it as a an, where an consisting of 1 by n, where n value is in between 0 to infinity. Instead of writing each and every term in the expansion, simply we can use the term of sequence that is called as an, and we have to define the n value from 0 to infinity. Then it is called as a simplified term in the expansion. Simplified term in the expansion. That simplified term is called as a recurrence relation. So, from the recurrence relation, what we have derived from 1, 1 by 2, then each term of sequence, we can derive the formula, that is an equal to 1 by n, where n is equal to 0 to n. From the sequence of terms, we can derive the formula, or finding the nth term in the sequence is called as solving the recurrence relation. Solving the recurrence relation. And we need to get the formula of the recurrence relation, we can apply the closed formula, or it is the explicit formula. What is the use of explicit formula? So, for finding the nth term in the sequence, we need to repeatedly applying the recurrence relation to find the nth term in the sequence. Once we can find the nth term in the sequence, that is the solution of recurrence relation. So, we need to find the nth term in the sequence is called as solving the recurrence relation. There are three methods to find the solution for the recurrence relation. First one is called as substitution method. It is also called as iteration method, and it is also called as backtracking. Second method is a generating function. Third method is characteristic roots. In this video, we are going to discuss about only the first method called substitution method. What is meant by substitution method? We need to substitute repeatedly. Why we need to substitute repeatedly? To find the solution to the recurrence relation. What is the solution? So, start with the first term, and this process is repeated until the nth term. Then this is the solution for the recurrence relation. Now, coming to the first method called substitution method. So, what is meant by substitution method? In this method, the recurrence relation for n is repeated. Here, an is repeated. So, why an is repeated? To find the general expression for an in terms of n. So, for example, consider the first example, how to solve the recurrence relation in case of substitution method. So, what is an? So, the recurrence relation has given an equal to an minus 1 plus n square. So, consider the recurrence relation an equal to an minus 1 plus n square. This is the given term. So consider as equation number 1. The first term has given in the sequence. We need to find the formula for the nth term. So start with already a naught. We know that is a naught equal to 7. That is already given in the question. Then start with n equal to 1. Then a1 equal to a naught plus 1 square. So don't to simplify the expression, just we need to expand the expression. A naught plus a1 square, that is a 1 square, that is equation number 2. Next, again a2. A2 means a1 plus 2 square. A3. A2 plus 3 square. Then you have to substitute this formula for the nth term. Then we'll get a naught plus 1 square plus 2 square plus 3 square plus 4 square and so on up to n square. A naught is 7. What is the formula for 1 square plus sum of n square? N into n plus 1 to n plus 1 by 6. That is the formula to find the solution for the recurrence relation. If you want, you can do the fractional fractions and we have to find the solution. So 7 plus n into n plus 1 into 2n plus 1 by 6 is the solution for the given recurrence relation. Second example. So solve the following recurrence relation by using the substitution method. An equal to an minus 1 plus 3 to the power of 1. What is the initial condition? A naught equal to 1 is the initial condition. So once the initial condition has given, based on the initial condition, we need to find the next term in the sequence. So what is the initial condition? A naught equal to 1 is the initial condition. Based on the initial condition, we have to find the next term in the sequence. That is n equal to 1. Consider n equal to 1. If n equal to 1, then a1 equal to 1 minus 1, that is a naught plus 3 power 0. What is a naught? A naught is 1 plus 3 power 0 is 3. Next, n equal to 2. Then in the place of n, substitute n equal to 2, a2 equal to a1 plus 3 square. That means we know the value of a1, that is 1 plus 3 power 1. 1 plus 3 power 1, remaining term is 3 square. This process is repeated for n terms, then an equal to 1 plus 3 power 1 plus 3 square, 3 cube, 3 to the power of 4 and so on. So all these are in the series of geometric progression. Then an equal to, what is the formula? 3 to the power of n plus 1 minus 3 minus 1. That is the 3 power n plus 1 minus 1. 3 minus 1 is 2. That is the solution for the recurrence relation. Because all the terms in the recurrence relation is in GP, then formula is a to the power of n plus 1 minus 1 by a minus 1. So a means the terms which are to be free, difference between the second term, third term and difference. That is nothing but a 3 power 1, 3 square. So that is the difference between the two terms. Then it is called as a minus 1. That is a is 3 to the power of n plus 1 minus 1 by 3 minus 1. That is 3 power n plus 1 by 2. That is the solution for the recurrence relation. Solve the recurrence relation by using the substitution method. First consider what is the initial condition. A naught is equal to 2 is the initial condition. Then based on the initial term, we need to find the next term in the sequence. That is an equal to an minus 1 plus n. That is equation number 1. In the place of n, substitute n equal to 1. Then a1 equal to a naught plus 1. Next, n equal to 2, a2 equal to a1 plus 2. Next, n equal to 3, a3 equal to a2 plus 3, a4 equal to a3 plus 4. This process is repeated for n terms. We'll get a0 plus 1 plus 2 plus 3 plus 4 and so on n. A0 value is 2 plus what is the formula for sum of n numbers? N into n plus 1 by 2. This is the solution for the recurrence relation using the substitution method. Consider the next example. Solve the recurrence relation an equal to an minus 1 plus f of n for n greater than or equal to 1 using substitution method. There is no initial condition, but we need to find the formula for the nth term in summarized form. Then first consider an equal to an minus 1 plus f of n. That is n start from n greater than or equal to 1 means we need to start the n value from 1, not from 0. So n equal to 1. In the place of n you have to substitute n value equal to 1. We'll get a1 plus a1 is equal to a0 plus f of 1. Next, n equal to 2, a2 equal to a1 plus f of 2. Then a3 equal to a2 plus f of 3. Then a4 equal to a3 plus f of 4. This is repeated for n terms. Then we'll get a0 plus f of 1 plus f of 2 plus f of 3 plus f of 4 and so on up to f of n. So a0 write as it is plus sigma. So that means n value starts from 1 to n or 1 to infinity f of n, or it is we take k is equal to 1 to n, 1 to n. So f of k. That is the summarized form of recurrence relation. That is a0 equal to a0 plus sigma k equal to 1 to n plus f of k. Suppose k is equal to 0, k equal to 1, we'll get the first term, that is f of 1. K equal to 2, f of 2, k equal to 3, f of 3. Like that we need to get the next term in the sequence. That is the substitution method. So what is meant by recurrence relation? What is the formula? How to derive the formula for the recurrence relation? And the first method for recurrence relation is substitution method. In the case of substitution method, we have to substitute repeatedly to find the formula for the nth term. Once we find the solution for the nth term, then it is called as the solution for the recurrence relation. Thank you.